this is Leon. Last year I designed and built my own Onewheel and documented the entire process here on the channel. And ever since then I've been seeing very similar reactions.
Not paying $1,000, I built my own Onewheel.
Still worse building a die Onewheel in 2026?
You should do a proper test video.
Yes, so let's do a proper test video and find an answer to those reactions. I can tell you this, I didn't go easy on this board over the past few months. I rode it on all kinds of terrain, smooth asphalt, rough gravel, wet grass and even the rare snow we get here in my city. So, let's find out, was all the work actually worth it? First, let's take a look at the board itself. Now that I've been riding it for several months and crashing it a few times along the way, the first thing you probably will notice is a broken corner on the footpad. Unfortunately, that didn't happen just once, it happened multiple times. I printed the footpads from carbon fiber reinforced PETG. It's a great material in many ways, but during hard impacts, it can crack more easily than I accepted. At some point, I realized this simply isn't something I can solve with a 3D printer. So, I reached out to JLCCNC. They're supporting this video by CNC milling my redesigned footpads from solid ABS, a tough engineering material often used in the automotive industry. JLCCNC is a contract manufacturing service for CNC machining and 3D printing. To order the parts, you simply drag and drop your 3D files onto their website. You select the material, shows the manufacturing process, and the system automatically calculates the price. After placing the order, production starts quickly, and in my case, the parts arrived just a few days later, even so they had to travel half around the world. What really impressed me was the surface quality. Clean edges, no visible tool marks, sharp transitions, honestly closer to injection molded parts than anything I could produce on my own CNC. JLC CNC machines plastic and metal parts directly from your design, and they also offer advanced metal 3D printing. So, if you're building something where material strength and precision actually matters, JLC CNC has you covered. You'll find the link in the description below. But upgraded footpads don't fix everything. Let's look at the rest of the board. Another weak point are the 3D printed bumpers underneath the board. They are regularly scraped against the asphalt when starting, stopping or maneuvering at low speed, and you can clearly see the wear over time. That's something I keep an eye on. Once the wear gets too bad, I'll simply reprint the parts and swap them out. So far so, I'm still happy with them and haven't had to replace anything yet. Apart from that, I haven't found any real damage so far. Most of the remaining parts are CNC machined aluminium. And the main load bearing components are made from 10mm thick aluminium plates. Because of that, I'm not too worried about long-term structural issues. Before we take the board outside for testing, we need to fully charge it. I'm using a self-built charger with a relatively weak power supply, which means charging from about 60 volts up to 74 volts takes roughly 3 hours. It's definitely not fast, but it's gently on the battery and that's a trade-off I'm perfectly fine with. The board is powered by a Vesc motor controller, which I control through a smartphone app. This allows me to switch between different riding profiles. My personal favorite is a profile called Chill Street Vibes. What I really like about it is the feeling. It honestly reminds me of snowboarding on fresh powder. When carving lightly from side to side, it gives the board a really smooth flowing ride that just feels right.
Over the last few months, I've riding this board on a wide variety of terrain, but most of the time I was on regular asphalt, and that's where the board really shines. Small flowing turns, almost like carving on a snowboard. That's where it feels the most natural. Balanced, predictable, smooth. Once I got comfortable with the setup, it almost disappears under your feet. From there, I start pushing it further. I tested a few inclines to see where the limits really are. 8 degrees? No problem at all. You can barely even see the slope on camera. 11 degrees? It's where it starts to get interesting. You can feel the load increasing, but it's still manageable. At 16 degrees, I could get a part of the way up, but eventually it ran out of power. To be fair, the battery was already pretty low during that test. Realistically, I did say somewhere around 15 to 16 degrees is close to the practical limit. And then I tried surfaces that are far less forgiving. On wet grass, for example, I accepted it to struggle, but as long as you keep moving, the grip is actually better than you think. What you absolutely shouldn't do is stop completely. That's when the tire tends to spin. And then there was the snow. We rarely get powder snow here, but when we did, I had to try it. With the pine tire, the board felt surprisingly controlled. After getting used to it for a few minutes, it actually became a lot of fun. Earlier, I compared the feeling to snowboarding, but now it was actually on snow, and strangely enough, it didn't feel like a snowboard at all. It still felt like a Onewheel, just on a very different surface. And somehow, that made it even more fun. After those tests, it was finally time to install the new foot pads. You have already seen them earlier in the sponsor segment. I redesigned the shape slightly to give the foot a bit more natural support, almost like it sits in a shallow footprint. While doing that, I also switched to a different type of pressure sensor. These are large seat sensors from the automotive industry. My hope is simple: a larger sensing area and a more reliable activation. The new foot pads gives the front a completely different look. And I'm still not sure if I like it better. But I'm curious what you think. Do you prefer the look with the new foot pad? And if you enjoy the video, a like or subscription is always appreciated.
To properly compare my board with off-the-shelf Onewheels, let's start with the raw technical specs. Without counting any time spent designing or building it, I spent roughly 1,500 euros on all components combined. The real-world range is about 30 kilometers, measured with me as the rider at a body weight of 89 kilograms. The motor delivers 4 kilowatts of power and was driven by a U-Box 250M motor controller, based on the open-source Vesc platform. For the tire, I am running a pin performance tire, which as you have seen offers very good grip. The smaller pin tire gives the board excellent maneuverability. At higher speeds, it's a bit less stable, but that's a trade-off. The total weight of the board is 13.9 kilograms, which places it right between the Pine X and the Onewheel GT. That's also exactly where I see it in terms of performance. Purely based on the numbers, it can compete with the GT. The downside is range. I'm using 18650 cells, not 21700 cells like the GT, which results in slightly lower overall capacity. Top speed. One important note about top speed: from a purely technical standpoint, the board is capable of reaching up to 70 km per hour, which is about 43 miles per hour. However, I only tested that speed with the wheel spinning freely in the air, without load. On the road, I deliberately never pushed the board that far. For me personally, I'll be honest, at around 30 km per hour, roughly 18.5 miles per hour, my courage runs out. Some people might call this being cautious. I'm perfectly fine with that. This project was never about chasing top speed. It was about control, wide field and reliability. Anything beyond that is more theoretical potential than something I actually want to use. Is building your own board worth it? Would I build a custom Onewheel again if this wasn't a video project or a passion project? If your only motivation is saving money, then the answer is very clear, no. In that case, you should absolutely buy a finished board. Developing a custom Onewheel, especially if you design everything properly in CAD and try to think through all edge cases, easily takes several weeks. If you put any realistic value on your time, a self-build simply doesn't make economic sense. There's also another important point. You almost always build one single board, which means you're building a prototype. Prototypes have issues. Commercial boards usually go through years of product development and are generally safer, more refined and more reliable. And then there's the question of responsibility. What happens if something goes wrong? What do insurance companies say if a self-built board causes an accident? There are no easy answers to that, and in the worst case, you're on your own. Why a self-build can still be worth it? All of that probably sounds very negative, but that's only one side of the story. For people who generally enjoy developing, planning and building, a project like this can absolutely be worth it. I learned an incredible amount doing this build, especially in terms of electronics, battery technology and safety considerations. You just have to stay aware of one thing at all times. You're riding a prototype, and prototypes can be annoying, impractical and full of surprises. That's why I was honestly surprised by how reliable this board turned out to be. I didn't expect it to work this smoothly. Finally, I want to give a big thank you to the people behind the Vesc system for developing it and making it freely available. Without you, projects like this simply wouldn't be possible for independent developers and builders. If you're interested in how I designed and built this board, you find the final build video linked here. And if you want to go even deeper, there's the full playlist on my channel, covering the entire journey across 5 videos.